So in today's room, we have intro to LAN, local asset access network, and into another pre-security room. So local access network topologies over the years, there has been experimentation, implementation of various network designs in reference to networking. When we refer to the term we are actually referring to the design or look of the network at hand. Let's discuss the advantage and disadvantage of these topologies below. Topologies. There's a little thing here, but we'll do it after we're done with the first task. So first there's a star topology. The main premise of star topology is that the devices are individually connected via a central networking device such as a switch or a hub. This topology is the most commonly found today because of its reliability and scalability despite the cost. Any information sent to a device in this topology is sent via the central device, to which it connects. Let's explore some of these advantages and disadvantages of this topology. Because there are more cabling and purchase dedicated network equipment is required for this topology. It's more expensive than any other topology. So we can see right here. Of course, you have all the wires connecting to it, to the one source. But what's good about it is if one goes down, it doesn't affect the others. It's more expensive. However, despite added costs, this does provide some significant. For example, this topology is more scalable in nature, which means that it's very easy to add more devices as the demand for network increases. Unfortunately, the more network scales, the more maintenance is required to keep the network functional. Increased dependence on the maintenance can also make troubleshooting faults much harder. Furthermore, the star topology is still prone to failure. A bit reduced. For example, if centralized hardware that connects devices fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often robust. Yeah, so I mean, this would just have to maintain much more to, hold all these accountable. The bus topology, this type of connection relies upon a single connection, which is known as a backbone cable. This type of topology is similar to the leaf off of a tree in the sense that the device leaf stems from where the branches are on the cable. Basically, all the data destined for each device travels along the same cable. It's very quickly prone to becoming slow and bottleneck. If devices within the topology are simultaneously requesting data, this bottleneck also results in a very difficult troubleshooting because it quickly becomes difficult to identify which experience which device is experiencing issues with data traveling along the same route. However, with this said, bus topologies are one of the easiest and most cost efficient to set up because of their expenses, such as cabling, dedicated network equipment used to connect these devices. Lastly, another disadvantage of topology is that there's a little redundancy in place of case of failures. This disadvantage is because there is a single point of failure along the backbone cable. If the cable were to break, devices can no longer transmit data along the bus. So like I said, pretty much there's one wire. So say this wire goes out, all these can still run, but this one's out. But if the mainframe goes out, this wire, then none of these can run. But, less cost efficient. The ring topology. The ring topology is also known as a token topology, boasts some similarities. Devices such as computers are connected directly to each other to form a loop, meaning that there's little cabling required and less dependency on dedicated hardware such as within a star topology. A ring topology works by sending data across the loop until it reaches the destined device, using other devices along the loop to forward the data. Interesting, a device will only send and receive data from another device in the topology if it does not have any to send itself. If the device happens to have data to send, it will send its own data first before sending data from another device. Because there's only one direction of travel, it's fairly easy to troubleshoot or any faults that arise. Oh yeah, another thing about the bus topology is like it is hard to tell. I mean, I know I said it, but it's hard to tell. It's more complicated troubleshoot, but with the ring, like it goes in one way, so you're able to tell where the fault is more easily. Interesting because, however, this is a double-edged sword because it's an efficient way of traveling across the network that may visit many multiple devices first before reaching the intended device. Lastly, the ring topology are less prone to bottlenecks, such as within a bus topology, a large amount of traffic are not traveling across the network at any one time. The design of the topology does, however, mean the faults such as cut cable broken device will result in an entire network breaking. Yeah, so one of these breaks all goes down. A switch. What is a switch? Switches are dedicated devices and within a network that are designed to uh, um, aggregate multiple other devices such as a computer, printers, or any other networking cable devices using Ethernet. The various device plug-in to switch ports. Switches are usually found in larger networks such as business, schools, or similar sized networks where there are many devices to connect to the network. Switches can connect a large number of devices by having ports 4, 8, 16, 24, 32, and 64 for a device plugged into. Switches are more efficient than their less counterpart hubs. Repeaters. Switches keep track of what devices are connected to which port. This way they receive a packet instead of repeating the packet to every port like a hub would do. It just sends it to intended target, thus reducing network traffic. So internet, router, switch. Both switches and routers can connect to one another. The ability to do this is increase the redundancy, reliability of a network by adding multiple paths for data to take. If one path goes down, another can be used. That goes down, all these can be used. Switch goes down, all down. If one path goes, while this may reduce overall performance of a network because the packet have to take longer to travel, there's no downtime, a small price to pay considering the alternative. What is a router? A router job is connect network and pass data between them. It does this by using routing, hence the name router. Routing the label given to the process of data traveling across networks. Routing involves creating path between networks so this data can be successfully delivered. Routing is useful when devices are connected by many paths, such example below. So if this router goes down, this path is done for, but we still have this path. Just why you should have multiple. Oh, don't look. Attached to this task interactive. That's the little thing. What does LNA stand for? Obviously, local access network. What is the verb given to the job that routers perform? Packets. Oh, routing. Obviously, bro. What device is used to essentially connect multiple devices on the local and transmit data to the current connection should be switches. Yeah, switch. Oh fuck. What topology? Cost efficient setup? The bus. Yeah, yeah, yeah. Oh my god. I end this the little mini game. So we go back up here. And they do have a video. The easier rooms, they have a video to showcase if you want to watch that instead. Whatever you want to do. Topology flaws. This lab will take you through the flaws in different network topologies. In this room, all devices are connected to whatever. Research one of the major flaws, right? If you hover over the middle of the network cable, you can cut it and see what happens back here. You cut it, everything's gonna go down, right? Can't travel anymore. Oh, is that it? I think there should be more. That's weird. Let's see if I can load it back up. Here we go. The bus topology, all devices are connected to a single cable backbone. Oh, we already got all this info. I didn't really look. Fuck. I think fuck, I didn't look. Alright. I'll follow y'all. Backbone data center to major flaw in the bus topology that it can't handle large amount of data. Yeah. On the next steps in the main pack, you can try and take down the network. Alright, so computer 1. We wanted to go to computer 5, the farthest. Just and then you're just gonna spam it. I'm just gonna spam it till the data gets overridden. I think I should go computer 3. Oh my god. There we go. Next be the star with the star. All devices are connected. Boom. Package sent through. See if you can somehow break the switch. Just a hammer. You break the middle, the mainframe. Boom, you're done. Yeah, the switch. Boom, you get the. If you need the. There's the flag. Alright. A premiere on subnet. So we privily discussed throughout the module so far. Networks can be found in all shapes and sizes. I think my laundry is done. I'm gonna do it real quick. Act like I don't. Alright, so I moved my laundry, but I already recorded this, and the recording messed up, so I'm a little pissed. So I gotta run through it back. As we have previously discussed throughout the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is a term given to splitting up a network into smaller miniature networks within itself. Things that slicing up a cake for your friends, that only a certain amount of cake can go around, but everybody wants a piece. Subnetting is you deciding who gets the slice and reserving such a slice of this metaphorical cake. Take a business, for example. You have different departments such as accounting, finance. So you have the internet router, then the switches. And then this example, they evenly disputed them. I said the word wrong. But in a real business, like finance would probably handle a little bit more because they have more workers, and human resources would take less depending on the business scale. And then accounting would probably be in the medium range. So just, take this into account when doing real life examples. Well, as you know, where we send information in real life to the correct department, networks need to know as well. Network administrations using subnetting to categories and assign specific parts of a network to reflect this. Subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by a number called a subnet mask. Let's refer to the back to our diagram for the first room in the middle. Octets go from 0 to 255, what it's saying. Subnet mask uses IP addresses in 3 different ways. Network address, host address, default gateway. Y'all can read this because I already read it, but the recording messed up, so I'm a little annoyed. But yeah, y'all can read it. Now on a small network such as home, you'll be on one subnet, as there are unlikely chance you'll need more than 254 devices at one time. However, a place such as business and office will have much more devices. All the essentials. Subnetting provides range of benefits including efficiency, security, full control. We come to explore. So they're doing a cafe example. They have all this equipment right here, and then they have their public Wi-Fi, and you don't want that, interfering with your private internet. What's the technical term for dividing networks up into smaller pieces? It's going to be subnetting, right? How many bits are in a subnet mask? 32. What range is section of octet subnet mask? Right, it's going to be 255 through 0, right? What address use identify the start of a network address? What address used to identify the devices within a network host address? What is name used to identify the devices responsible for sending data to another network? What is this? Switches? I mean default gateway. I'm just annoyed. Honestly, I already did this shit. Now I'm redoing it again. Shouldn't I want to get my laundry? ARP. Alright, so ARP, recalling from our previous test that devices can have two different identifiers, a MAC address and an IP address. ARP is going to be address resolution protocol, technically responsible for allowing devices to identify themselves on the network. Simply, ARP allows the device to associate its MAC address with an IP address on the network. Each device on the network will keep a log of the MAC address associated with other devices. When devices wish to communicate with another, they will send a broadcast to the entire network searching for specific devices. Devices can use ARP to find the MAC address and therefore physically identify a device communications. How does ARP work? All it is, device with letter has letters store information on which is called a cache, however you pronounce that. And the context ARP is a cache that stores identifiers of other devices in the network. In order to map these, so it's going to have ARP request and ARP reply. When ARP request is sent, messages broadcasted on the network to other devices asking what is the MAC address, that's the own IP address. When the other devices receive that message, they will respond if they own the IP. And it will send ARP reply with the MAC address. This requesting device can now remember and store it in ARP for future use. So you can see it's gonna ARP request, then it's gonna respond, I have that IP. Boom. What does ARP stand for? Address resolution protocol, right? Category MAC address. Wait. This way you need to read the questions. Bro, I'm just a little annoyed. What category of ARP package ask a device whether or not it has? It's gonna be request. Oh my god. What is the address is used as a physical identifier for a device on network? MAC address. What address is used logical identifier for a device on the network? It's gonna be your IP address, right? Common knowledge. But these are beginner rooms, so if it's not common, it will become common to you, right? IP addresses can be assigned or either manually by entering the physical into device automatically, and most commonly using DHCP, Dynamic Host Configuration Protocol. When a device connects to a network, if it has not already been manually assigned on IP address, it sends out a request, DHCP discover, see if any DHCP servers are on the network. The DHCP server then replies back with the IP address. I could use DHCP offer. The device can send a replying confirmation offer, DHCP request, and lastly, DHCP sends a replying acknowledge has been completed. DHCP, if you ever see ACK, that means acknowledge. So you see the discover, it's asking if it has any, then the offer is going to be, yeah, I have it. Now they say they have it. Now they'll see if they want it. And then if they want it, they'll request it. And now you have the final acknowledgement saying, okay, I've shown you it. You want it. Now I can approve it. It's really simple. What type of DHCP packet uses a device to retrieve an IP address? Can be discover, right? Because that's how you're going to search for the IP, right? Package does a device send once it has been offered an IP address? A request, right? Because it's just been offered one, now it's going to request to use it. What's the last one? It's going to be acknowledged to confirm that it's set in stone. All right, and boom, showing the OSI model. I already made a video on that, so go check that out. Sorry if the second part was a little down because I already made it. It's just kind of annoying. But yeah, more videos to come, and these are just the beginner rooms of pre-security.